Solving equations and formulas. This is probably the hardest section in this chapter, and luckily it's also the last section in this chapter. The trick is with these is to remember your basic algebra rules on how to move what around, your orders of operations, how to solve for a variable, the basic rules. You need to make sure you understand those and know how to use them. Try not to get overwhelmed about what the type of problem looks like, because looking at the examples from the notes, the first one says 5b plus 12c equals 9, and it says we're going to solve for b. So there are two variables in here, which is a little daunting at first. Plus 12c equals 9. We're going to solve for b. So, as I mentioned before, it may be a good idea to kind of highlight, underline, square, box off, circle the variable you're solving for, so you know what else to move around. So you know, make sure that you don't lose your variable that you're solving for. So we're going to solve for b, and put a little box around it. Okay, so think of this problem as something different. Think of it as 5b plus 12 equals 9. And I'm going to kind of do that off on the side. Hopefully I have room. So if you think of it as 5b plus 12 equals 9, the first thing that you would do, as we already talked about, was to move the 12 over. So we're going to subtract 12. And that cancels the 12 out. Sorry. So in the red problem, the original problem, we're going to do the exact same thing. And it's okay that it has a c with it. So we're going to move the whole thing, 12c. Okay, and you may be looking at this thinking, I can't subtract 9 and 12c because they're unlike terms. Well, that's right. But we can still rewrite it so that looks okay. Because I didn't actually subtract it. I didn't get one number or one value. I just got 9 minus 12c, which is exactly what we did up here. And that's what we did here too, 9 minus 12. We just didn't go ahead and simplify it. So now that you have something like this, and in the case for over here, it would be 5b equals negative 3. So in the case over here, we would go ahead and divide by 5. And we would get some number. So you do the exact same over here. I'm solving for b, so I'm going to go ahead and just divide everything by 5. And yes, you do get some absurd fraction as an answer. But that's all that you do. Nothing else, no more complications, that's it. Okay? So the most basic thing to remember, again, is all your rules, how to move stuff around, and also change it into a problem that you know how to work. We know how to solve this problem, so I use that as an example, as a guide. The only case in here is that we can't simplify anything because we do have that 12c. So, but we just leave it there, leave it as is, and then continue on. Okay, the next example, I'm going to do the same thing again. Is we're going to solve, can't read my writing, 7x minus 2z equals 4 minus xy. 4x. Okay, this one can be a little bit tricky later on. We're going to actually have to think way back to a different type of problem to find the final answer to this. So we want to solve for x. Now, if you notice, I have an x here and an x here. So this takes us back to variables on both sides of the equation. So if you don't remember how to do that, go back to that tutorial and refresh your memory. And then come back to this one and you should be good to go. I do want to make sure I get all my variables together on the same side. And as I mentioned before, when you're moving your variables, you're going to take your coefficient that's the smallest and you want to move that one over. So in this case, I have a 7 in front of the x. In this case, I have a 1. So I'm going to move this one over. And it's a negative, so I'm going to add it. And that y is attached to the x, so you have to make sure you carry it with it. So now I have the variable that I'm solving for on the same side, which is what I wanted. They're on the same side of the equal sign. They're both on the left, which is good. So I still need to move some other stuff over. I need to move this 2z over. So I'm going to add the 2z. And then I'm left with 7x plus xy equals 4 plus 2z. Okay, here's where things get a little tricky. The left side should look like the final product of a distributive property. And again, you don't remember your properties, go back to the presentation, review your distributive property and what it looks like. When you finish a distributive property, you actually have the same thing on both sides of your operation, whether this be addition or subtraction. So I can actually do a backwards distributive property, and I can take out what was multiplied in. So because these are the same, the x and the x, I can actually pull that out of this side. And what that looks like is 7, or x, I'm sorry, parentheses. And then after I take the x out of here, I'm only left with a 7. And after I take the x out of here, I'm only left with a y. So now I'm left with x times 7 plus y equals 4 plus 2z. Just like before, when we have a variable that we're trying to solve for and a number or something, we're going to divide by that something to get rid of it. So again, this looks a little crazy, but that's what we're going to do. We're going to divide both sides by 7 plus y. So x equals, and then that huge fraction on the other side. And that's our final answer for that problem. Then you just have one more. And this is a word problem. It gives us a formula for finding the volume of the cylinder, which is V equals pi r squared times h. Then it tells us in part A that it wants us to solve the formula, this, for h. So we're going to solve for this variable. This variable is being multiplied by pi and r squared. So just like before, whenever we're multiplying, we're going to get rid of that by division. So I'm going to divide both sides by whatever's being multiplied by the h. So you get volume divided by pi r squared equals the height of the cylinder. So that's part A. Part B wants us actually to use this formula and to substitute some numbers in. It later tells us that the radius of this pool is 12 feet. And it tells us the volume is 1,810. Cubic feet. So then we just take these two variables and we substitute them in our formula that we just solved for in part A, and then we should get the final answer. So they're going to put 1810 over pi times our radius, which is 12 squared, equals h. And then we just solve from there. Whenever you do your calculations, you should get that the height is approximately, and the squiggly equal sign means that approximately 4 feet. And there was part B.